here is the upstairs part of the office, and we're hosting the Kubernetes CNCF Helsinki meetup for today. If you didn't find it yet, feel free to go get a drink from the end of the hallway. And any questions you have about the place, you can ask Siri there in the corner. And yeah, I don't think I have much to say at this point. I will do a better introduction when my presentation starts. But welcome everyone, and hopefully you will enjoy the presentations.
All right. Well, welcome also from the organizers, and welcome to Kubernetes CNCF Helsinki meetup. We are part of the CNCF ecosystem. We have 3 talks today, talk about pitfalls of over-engineering, under-documenting, then cross-plane lessons learned, and how Helm File supports Kubernetes DevOps platform by our kind host, Martti. And CNCF and Kubernetes Finland is part of the Cloud Native Nordics, which are based in a couple of cities across the Nordics. There are some vibrant ecosystems in here, and I'm very I think it's a very good meetup group if we think about, reviving all the developer ecosystem post-COVID. It has been very successful, and it's growing constantly, so new members every time joining in. And of course we follow to the Linux Foundation code of conduct, so in short, be nice and respectful to each other and include everybody. There are options for joining the community, so there is the Slack channel, of course, everyone is welcome there. You can find a lot of information like what is going with events, if there's questions to be asked, and so on. And usually links to the other events happening across the Nordics, like we are today having the live stream here, so if you cannot join in person, of course it's preferable to join in person so you get the kind of networking experience. But if you can, then it's possible to watch the live stream also. And we're of course looking for new speakers. We got 3 very nice speakers today, but of course if you have something you would like to present, if there's something that you are interested in, it doesn't need to be always, I think, at least my opinion, it doesn't need to be something like super professional. You don't need to be a super professional on some topic. I would like to see some very kind of interactive discussion also in these meetups. So you can of course reach out to us on the topics you would like to talk about or submit a proposal.
And you have time, the next open slot is in January.
That's right. Next open slot is in January. But Lucas, can you talk about a little bit of CNCF?
Hi, from my part as well, I'm Lucas. So how many of you are here for the first time? Okay, nice. Welcome. So CNCF stands for Cloud Native Computing Foundation, and it's a non-profit foundation that, let's see if I actually get this, yeah, good. Non-profit foundation that kind of acts as an umbrella for all of the projects so that they can work together nicely, and companies can collaborate under the same roof without being worried about immaterial property conflicts and that kind of stuff. CNCF does a lot of other things as well to help and make their communities vibrant in this space, such as organizing events. They also help in different ways for the meetups and those kind of stuff, and also provide projects with resources such as documentation and other benefits. Then it has all kinds of different things. What is maybe the most important here is that they actually have, for selecting the projects that are part of CNCF, they have a technical oversight committee that kind of consists of technical experts from all kinds of different fields that chooses the projects that are of really high quality. And then also they have end user communities and all these other kinds of many special interest groups, user groups, all kinds of these. So there's many ways to get involved, and these kind of hundreds and hundreds of meetups and events every year. And the way that the project is classified is that the sandbox is for the kind of entry level. So if you have a cloud native project that you want to make sure is kind of under a vendor neutral umbrella, then you can, if it kind of satisfies some basic criteria, then you can donate it to the CNCF at the lowest level. But these are for the kind of experimental projects, experiments and these kind of things. But then the incubating phase, you have a lot of quite many production users already. It's a vetted project. It's a good maintainers, some good CI/CD and that kind of stuff. But then when you actually cross the chasm and you know the big banks start using it and other kind of for other mission critical projects, then it kind of is possible. And when you have maintainers from all kinds of different companies and checklists and this kind of stuff, then you can achieve the graduation phase. And CNCF has 20-ish graduated projects, but then like 100-ish sandbox projects. So it's kind of they grow in numbers as the maturity goes down, but then the graduated ones you really can bet your business on. So like Kubernetes is of course one of them, already graduated many years ago. There's Containerd for running containers, Prometheus for monitoring, and all kinds of other stuff. I think that actually was on the next slide as well, yes. So here are some really mission critical projects you can use everywhere. And as I said with the kind of technical oversight committee, these actually make sure that is this project, you know, technically good, does it have a good community, and all of the, you know, how does it fit into the ecosystem, and how production users actually use it, do they get value, and so on and so forth. So these are the kind of, these you can take into use absolutely today, and you could already have many years ago. But then incubating projects grows in number, more of them. Many of these are really good as well, really high quality, but still have a little bit to kind of get to the mainstream part where everybody kind of uses it. And then I think, yeah, Sandbox is like everything you can imagine, but these are also very interesting projects. These are perfect ways to kind of pick one, you know, try it out, and then kind of tell here about your experiences and these kind of things. Many of these are the kind of future cornerstones of our infrastructures, and yeah, good place to contribute if you want to make an impact on kind of the direction of the cloud native ecosystem, for sure. Then on the kind of what else does CNCF do? Well, they made this kind of GitHub repo many years back. So CNCF is founded in 2015. They made this GitHub repo to which you can submit a pull request if you have made a cloud native project. And this kind of this grew very quickly. Now there's like the logos are really small if you kind of would fit them all into one screen. And that is the landscape.cncf.io. They gather this, they gather all of the members, they make all kinds of surveys and kind of reports from end users, and kind of make it easier to kind of find your path within this ecosystem, because like hundreds of projects and like CNCF has 800 member companies as well, and even more that are using and contributing to the technologies. So kind of they help you with these kind of different kinds of resources, help you navigate this vast ecosystem. Just Kubernetes, the kind of most active of the CNCF projects, has 80,000 contributors last time I checked. So that's kind of we're in the top 3-5 open source projects in the world with these kind of things. of the certifications.
Yeah, so there are different ways that you can learn more about Kubernetes, and they are providing some certifications that you can follow or some resources that you can learn more. There is this Kubernetes MOOC that you can take, it's a free course. And then the certificates have different levels, starting with this CKA, the administrator level, and then application developer, and the highest one is security specialist. And I see one more, which is associate exam. So you can go through these certificates, study for the content of the certificate, and learn more about Kubernetes and the details if you like to. And well, there is a list of other additional courses as well within the more detailed subjects. Then something also new for me. Kubernetes certified service provider. I think this is the thing that if your company, if there are people in your company that have got these certifications, then and there are enough number of employees who have certifications, then your company can apply for this certification, which is called service provider certified. Yeah, the requirements mention that 3 or more engineers who pass the CKA exam. And then certified Kubernetes conformance, also something else for the companies.
They provide a service.
Yeah,
The Kubernetes.
yeah. If your company provides Kubernetes service, then your company can also apply for this certificate. And about the community, well, this is one of the places that you can come and join the community, these local meetups that we have. Then there are other things that you can involve yourself more with the community. For example, the mentorship program. The CNCF has this mentorship program that you can follow, and there are community groups, and there is community days. Different countries, different cities within countries have these community days, which, for example, UK one is coming up, and you can also follow those events and also present talks there. And the main one is KubeCon and Cloud Native Con, which the next one is in November. It was in Chicago, the North American one, and then there is also one in Europe, which was in March in Paris. So
Highly recommend.
yeah,
Definitely.
the main thing. So if you are willing to learn more and be in the community more, you should attend this.
When does the ticket sale for the Paris event start? Because it's like
Usually it's
a month earlier than usual, almost 2 months. So because
yeah, it's
earlier
quite,
went
quite
on sale in December, so I think
Yeah,
it
I
should be pretty soon
yeah.
that.
I think that November, December time.
Yeah.
Yeah. And they do sell out, even though they have, like last time now in Amsterdam there was 10,000 tickets or something like that, if I don't remember incorrectly. But even with that, they sold out. So, and then yeah, in physical, and then there was 20,000 more virtual or something. So
Yeah.
it's quite a big thing, and highly recommend going. But
Yeah.
make sure to get the tickets early.
Yeah,
in Paris, so book your hotel early.
Yes.
Yeah, the early bird tickets are much cheaper, and
Yes.
also the virtual one, I think it was
Something like that. Yeah.
$15 for the North America one, so pretty cheap if you are quick. And then also the call for papers for this one, for the Paris one, is open if you have some ideas if you want to submit a talk. And then I'll
Even-
pass.
Even also, if you can't go, any talk that has ever been presented at KubeCon is also available on YouTube. So there's lots of good content there as well.
Yes. I'll pass this one to.
Yeah, so it's my favorite jobby to organize developer and community events. So I'm helping to organize the FooConf this November 7th. So let's say, it was inspired because there aren't no like big architecture and developer conferences like agnostic ones in Finland. So we thought that let's make one with a couple of my Swedish friends, and we did this first time already this
February.
January.
Yeah.
February. That's right, and we want to make this an annual event. So the tickets are already on for sale, and I make sure that we get some discount codes which I'll be sharing on the Slack. Yeah. And if you want to know more, please ask me. The schedule is online already. There's plenty of very interesting talks.
So that's definitely the closest. It's not only, as you said, like not only Kubernetes and these kind of things.
That's right.
Everything with
Everything.
software. Yeah.
Yes.
But so that's the closest one if you want to go for a longer conference. And the next closest is Denmark, in a Kubernetes community base in Denmark in
There's
mid-November.
No missing in front of the Twitter. Formerly Twitter.
That's right. True.
Yeah. No comment.
Let's exit.
All right.
Yes.
Channels to reach out to us, and I think we're about time. So let's give the slot to the first speaker. Oh, the next meetups. This is important. Sorry. The next one at Relex on November 22nd. So we're gonna talk about mostly about supply chain security.
Text is slightly behind.
Oh, I'm sorry. Talk about supply chain security, and then let's see if we do something in December. That's in the kind of early planning stage still, but then the next actual meetup will be in January at Yle, February at AlphaSense, and again for those are TBA. So if you want to talk, there's slots available for the January 18th event.
Yeah, cool. Any
I think it would be quite cool to have a meetup during Slush Week. Is it possible the 22nd, if we could move it up to like the 29th or the 30th, because there are so many international visitors who probably would like to participate.
We had one in 2018 maybe.
Yeah.
And it was quite cool to do that as well.
That's what I was thinking.
But unfortunately the calendar didn't line up this year for the organizers at least. But if you're interested in organizing, then of course get in touch with us and we will definitely help out and schedule another event. But yeah, for us at least, that wasn't possible. But yeah.
Yeah, and for at least for me, there's so much happening on the slush week, so difficult to stretch. But if someone else wants to do that, then definitely make it happen.
Yeah.
Okay.
Yes. Then we take a short 5-minute break or something like that, and then
For setup.
get you set up. And yeah, kitchen was that way.
Yeah.
Right? Or,
The drinks
Yeah.
that way. And toilets also.
Yeah.
takes. See, that works. Always when somebody says, all right. Good morning.
Good morning.
Ish. We're IT, so it's morning. Apparently, I'm the warm-up act here today, so I'll not get too technical. I'm going to be a storyteller today. I'll have very little time, so if I speak too fast, just tell me that's too quick. Quickly, what I'm going to go through. As you know, the topic is over-engineering under documenting, which, of course, none of us ever do. Right?
Absolutely.
And has never happened. Nobody had ever seen anything like it. So I'll do a quick intro on myself, then it's about 27 minutes long. And for 3 minutes I'll talk about the thin line, the over-engineering. Now the thin line to dance with, over-engineering, I have 2 examples, under document I have 2 examples for you guys. And then a formula to success, and this is based on my experience. Not necessarily something you take to the bank and go like, if we do it this way, it'll always work. Probably not. But at least in my years, I've seen those. And then if there's questions, which I really hope there isn't, then we can ask those. Right, so who am I? Some of you know me, and those who don't. So I was born in Germany. I was raised in Mexico. I graduated in the US and the UK. I've lived in 6 countries, and I've never done anything but IT. I started by soldering 86 chips onto motherboards and went from there upwards. That means I was on the internet pre-Google, and there is only a handful of people in here that can say that. There you go, see? Go InfoSeek. And those of you who don't know, that was pre-Google. There you go.
You're going way back.
Using finger and gopher in text-based.
Exactly, there you go.
Been there, done that.
So we have a few laughs, that's good, okay. Ice broken. I've worked in any position in any size of company, from help desk all the way to being a CEO. Lately I've been an entrepreneur. I've built a cloud company in the past and was a corporate slave before that, no problem. I've been cloud native since 2013, which was back then a little bit of a stretch and heavy thing to do, but you know, we weren't quite as advanced as today, 10 years ago. Yes, I have certifications, including the CKA and whatnot, but I have to say I usually do them so that I have some sort of credibility with a bit bigger corporate customers, because you know the HR person always asks, do you certify? Yes, here you go. Okay. I've built and designed large private clouds, large Kubernetes clusters, massive clouds or cloud environments, and then a lot of automation in my time, and that's where the war stories come from. The examples. That's the one, sorry. Yes, I do have a life outside my computer. It's not very big, it's about 15 minutes a day, but it includes, you know, the SFC, sports, kids, and cars, like some of us do. But that's enough about me. If you want to hear more, you can talk to me after. I just need to run. So, the thin line to dance with, and this is where the whole over-engineering and under-documenting becomes this kind of like tightrope dancer. Automation is great, but not everything can or should be automated. It seems that a lot of people nowadays seem to think that automation, especially in the corporate world, automation is the golden nugget for anything. Like, can we do it automated? Yes. Should we? No. But that is the line where you need to draw then, you know, the balance. Should this be or shouldn't it be? Security automation, at least in my experience, works great for enforcement. Fantastic. You know, you keep locking those developers down. Sorry, by the way, any developers. And you get your notifications, and it's all great. But as soon as you need to do any kind of actual interactive reaction to it, automation either produces a lot of false positives or nothing at all. I've been to a customer where exactly that happened. So they had one day 60,000 events and actually nothing had happened. But you have to weed through them. And then we come to attitude adjustment. I love this quote, and I don't know if anybody has seen Peaky Blinders, but it's fantastic. Why? Because we can. And if we can, we do. Don't, not always. I mean, keep your head, on the ball. And then there's the cause, effect, and maintainability. The struggling is always usually engineering, and I include developers here, myself included, even though I may not be the developer, and management. It's like talking two completely different languages, because you can blabber all week, and then the manager goes, okay, or no, why? I didn't get it. So there's always that, you want to, why, and how do you maintain it? Always think outside the box. Fair enough, no problem there, especially when it comes to automation. But implement it simply. Some people seem to think that it's really cool to do the new stuff, and that's fair enough. That's why it's there for. We innovate, no problem. But then implement it so that somebody else can read it too, and not Perl one-liners. From what I've seen, at least in my years of experience, automation should be there to help things forward and not to, block things, which happens a lot of times. I've seen cases where fixing the automation took longer than if you actually would have just done an interactive automation chain all along. So, like I said, it's a thin line to dance with, and sometimes you nail it and sometimes you just don't. Fair enough, but it's something to keep in mind. We're all still awake? Cool. I need to speak slower. So, example number one. Sorry, war story number one. Over engineering. The premise goes that it was on AWS. They had a GitLab running on top of a Kubernetes cluster inside the cloud environment, and the object database for GitLab was run on S3. In itself, maybe not something I would have done in that instance for what they were doing, but okay. The original deployment had 82 different launch files. And they all were referenced and checked before the deployment went through. That alone took 25 minutes, by the way, in the cloud environment. Nothing had happened. It just was verifying and checking and verifying and checking and verifying. And instead of upgrading when they were, new version came out or whatever, they did a blue-green deployment, meaning they launched the exact same copy aside with maybe a patch version, restored the database into that or stopped the other one. So you couldn't do anything, no commit, no nothing for the entire duration. You could read from it though. Copied the database over or the reference files, restored it, hoped for the best. And when it was confirmed with the automatic script, then it automatically deleted the old cluster. There was no human interaction here, which means if you got an okay, but some objects were not properly migrated or something happened, it still wiped the old cluster off. Runtime without errors was between 6 and 10 hours. And they did this once every 2 weeks. This was sold, by the way, by a contractor that really went over engineering overboard. Now, the cool part was that if you wanted to install a new environment, you had to edit, I think it was 16 different files with the exact same information I may add here. Like not that you would, a name and a version. No. Name, version, repo, and image version. Then you copy that information and open 16 more files and reference that in there too, because apparently the original author couldn't comprehend that could just one file. The programmatic users, as in automation users, were 16 that were required for this deployment. Bear in mind, this was not a big GitLab deployment, okay? This was, I think it had maybe 60 users at best. And then, of course, they had the remote database migration. So when you boot GitLab up, you need to make sure that the newer version migrates, does the database migrations. They stopped working as soon as the contractor left, and nobody knows why. But this was, it was then taken, oh, well, then we just, it throws an error, that's it, it's okay. So in order to mitigate that, one of their engineers actually put a version stop, so anything past version, I don't remember what it was, let's say 9, will not be implemented. Any hot patch or any patch, 9.1, 9.2, that's fine, but nothing 10, ever. So by the time we got to it, there were 5 major versions behind, and that was a small pita. And I'm keeping my language as clean as I can, by the way. It's a struggle. Now, the worst part about this was that during this entire deployment process, they had 0 confirmations or interruption breaks that you could actually say, okay, you know what? Somebody needs to actually check this out. It ran for 6 to 10 hours. You prayed, and after 6 to 10 hours, either the cluster was up or it wasn't. And if it wasn't, that's when you got the logs. So then you postpone it for the next day. This was over-engineered pretty well, in my opinion. It sucked to fix it, but that was like impressive. Did I mention no documentation, by the way? Comments? Ever happened to anybody? No?
How is it possible it took 6 to 10 hours?
Because there were so many loops in there. So AWS, if I would have deployed it, I would have just deployed the cluster. Fair enough, do the basics. What they did is half of their deployment scripts were Lambda functions that referenced and fetched information from God knows where. And
sorry, that was spontaneous.
yeah, and on point. I did the same thing. I almost cut my wrist when I saw that. So by the time this loop comes back, it took like a minute. And then they didn't just have 1 or 2. They had like hundreds of them. That it cycled, even if they were not necessary, they cycled through all of it for every step of the deployment. So it's kind of like running 200 database queries, and every one of them starts with select star from. So it just took time and time and time. I mean, we were sitting there like, okay, what does it actually do? And you can see in the logs then later on, waiting, waiting, waiting. So yeah, that's why it took them ages. And to be fair, in that particular instance, that AWS environment wasn't the fastest. Anything else? No? Still awake?
So you fixed it then
Yeah.
later? Yeah.
We basically rewrote most of it from scratch. Like, it just, you dug into the code and you were just face palming yourself day after day after day, and because it wasn't documented, so half of the Lambda function, nobody knew what they were actually doing. But if you disabled it or renamed it just to see what happened, it stopped right there. Why? Because it couldn't be found. So.
But it did leave room for like speed improvements if the management comes and asks for those.
Very much so, yes. So, yeah.
That we leave the sleeps on the scripts everywhere.
That's true. That's true. Sleep 20, sleep 100. Yeah, definitely, yes, of course. And if you're a good contractor, good engineer, you put those in automatically. I think the biggest problem was that the original author of this, they just made crazy stuff so they don't have to put the sleep in there.
They're hiding their sleeps.
Exactly. Very well, I may add, because I didn't find any. Over-engineering example 2. So this was a front-end production container application. Looked very cool. Didn't work very well, but it looked very cool. Running on a VMware-based Kubernetes cluster with data ingested from Azure twice a day. To this day, I do not know why they ingested data from Azure and not push it directly into it, but that's not for me to ask. And the database was a distributed PostgreSQL on the same cluster, which, fair enough. The automation had a multi-stage. It started with a Terraform to build up all the instances. They had a very weird customized Linux image to boot the nodes up with, and half of the packages needed weren't pre-deployed into it. So it booted up and then it started updating and installing itself. Oh wow, Ranger. Sorry, typo, it's a Rancher. They used the Rancher 2 CLI to provision the cluster then with the templates that had variables in, nobody knew what they were doing. And they had actually cool names because they started with like 1x, 216, and you're like, what is this? I don't know. Okay. And then the deployment of the web app happened right after the deployment of the cluster. So as soon as the cluster gave, you could go, they pushed it in. It was one single script from beginning to end. They also deployed Longhorn. I don't know if anybody knows Longhorn here. Yeah, in a really, really, really bad way, like terrible way. But their IT department decided that was the way to go. And the IT department was not cloud native at here. So they had no clue about anything cloud related. There was 23 deployment scripts and they were all chained together. So it was like 1, 2, 3. They actually were named 1, 2, 3 all the way to 23. And they were referenced back and forth to specific parts into each other during the deployment. So it was like really weird because halfway through it also script 18 referenced script 5. Ran part of script 5 as a function. Went back to 18, went to 19, who then referenced 7. And like it was like a glorified mess. We had one interruptions and confirmation where people then could say yes or no, and that was when you launched Terraform. Do you want to start? Yes. Okay. And that was that. After that, it had a life of its own. Support from the team that built it, 0, because they all had left already. It was a contractor that thought that they sold the coolest thing ever to the client, which they did, because the client didn't understand what they were buying, and then the developers went basically all out because they needed a new line on their CV. I built this with, I did this, yeah. We had some documentation, and I shit you not, I'm not making this up. The wiki page said, here be dragons. That was the documentation. We were all like, joke, scroll, nothing. Just here be dragons, nothing more. Okay. Yeah, so the problems that arose and why they actually called me and one more other guy in was that they needed to upgrade versions and they couldn't because the scripts referenced or had hard-coded specific versions into it. And as soon as we changed the versions, it all just went, nothing worked. It launched the cluster and it started deploying the web app and then it hung or failed or created an error or anything. So anything you wanted to change, you couldn't easily. It was all hard-coded in, so none of it was automatic. And then, as I mentioned, the Longhorn deployment, I do not know to this day how they did it, but they deployed it so that even the disks were hard-coded into it, the disk labels and disk names into the deployment. So if a virtual machine, by whatever reason, VMware created another disk label, or it happens, these things happen, or SDB wasn't present, it was automatically renamed to SDC. No, can't continue, you don't have SDB. Yeah, but, no, sorry. And then the problem was you couldn't stop it. So then it started building a cluster, had 1 node dead out of 3, didn't clean, but because the script just continued, it tried to deploy the web app for a couple of hours, which didn't obviously work, until it then went into timeout and said, yeah, we can't do this, kill. I think this took the better part of 6 months to fix, to actually get it properly running. And they were very happy in the end when we actually cut all the crap out, but that was not a pretty thing to do, so no. Comments? More war stories? Sleeping?
They're fun.
I know, right?
But did you say they're fun?
Yeah,
Yes.
war stories are fun. It's not when you're in it, that's not fun.
No, I just feel like you're sharing your nightmares.
Yeah, but that's the fun part. I share so you don't have to.
And then if there are parts that, okay, this is how we fixed it, that's also fun.
Well, yes and no, because that usually involves a lot of sleepless nights, which isn't then fun, so.
No, just telling about it afterwards, how it was done.
This also was a complete recode. Like, we started again from scratch. We tried to reverse engineer and look at the stuff, but the scripts were so back and forth, and we couldn't make sense of any of the variables and function names and deployment names that they had used, because normally you would do something normal. They were all numeric. Like, what the hell? You look at it, I think, yeah, we wrote a script that extracted all the variables by name, and it was like a list this long with just numbers. There's no sense in them. So yeah, we basically ended up rewriting it and take most of the crap out. That was a big speed improvement, by the way, for some reason. No sleeves. Okay. Yes.
So did you also perform a rollback, or you kept the system like broken, like holes?
Well, we didn't have a choice. I mean, they were running that application, and they tried to launch. So the web app was internal, okay? But, and here's the big but, it was internal, but it was about mission critical, but they tried to deploy it in different regions. In Germany, it worked, and nowhere else. So the workaround was basically, for the time being, we guided everybody to the German instance, which was quite crappy, because if you're sitting in China and you need to access a web app in Germany, that's slow on a good day. On a bad day, you can't use it. Especially when you're talking about, they use this for testing processes or testing reports on car interior designs and whatnot. So if you have a latency of a second, it's just not usable. But at that time, we had no other choice, because we tried maybe for 3 weeks just to get one instance up running somewhere else, and you couldn't. It just didn't work.
So scalable not?
Not so much, no. Semi-scalable. I've scaled once.
So do you think this is over-engineering or just bad engineering?
No, this is over-engineered. The amount of bad engineering would be if you hard code stuff in, but the way they actually went over the scripts just because you can. So they try to be the cool kid by,
Minimizing amount of characters.
Yeah, exactly. We reference everything and we make it all nice and cool, and I'm pretty sure on a flowchart it looked fantastic. The whole process. It was probably like one of those cases that you want to show people. Reality, probably not so much. So it was over-engineered because they spent so much time writing so much unnecessary stuff into that it made no sense in the end.
So roughly what kind of solution did you end up with?
We ended up, well, they had an internal requirement to use Rancher too. So we kept on that and built the deployment based on that with templates that made a little bit more sense and deployment scripts that made a bit more sense. We also implemented a pipeline stoppage that had a human deploy the web app, confirming that the cluster was actually up and running. And then before it went actually live and opened the internal ports in the firewall, they verified again. So we actually implemented API checks that check that the application works, not just that it's there. So before they checked if the container was there, not even running, just there. I was like, yes, okay, cool, it's running. No, it's not. So yeah, we ended up using that, and I think we ended up with 3 scripts all in all, maybe 4 on a bad day.
Were they referencing to each other?
Yes, of course, obviously. but we weren't referencing in the middle, we were always referencing the front.
But you at least have numbered variables.
No, we actually switched to just A, B, A, C, A, B. So, just to make things interesting.
So how did you name your scripts? 1, 2, or 3?
No, I think they were start, middle, end, and supplemental. Yeah.
And if they required Rancher, I wonder what's the state at the moment, because if I recall, Rancher ain't there no more.
Honestly, I don't know. This was about a year and a half ago. It still gives me a nightmare to this day, but still, I mean, they haven't called me yet, so they're probably using it still. It's also, I classify this as heavy industry, so they're fairly slow on doing anything. And since they bought the license, they probably get, and they have a support contract, they probably get updates still for a couple of years. Cool? Okay, next one. Under documenting. Fantastic. Yeah, this is actually the problem with most customers that I go to. So usually I'm the guy that they call when the proverbial beep has hit the fan already and it's dripping. And usually when I ask for documentation, I get a link and then you go through it, and that's where we found the Here Be Dragons, but in this case not. They had a production Kubernetes cluster, and they had a mission critical application on it. Fantastic. They also used OpenSearch for monitoring and analysis, which, fair enough. It was not hosted on that cluster. It was separate, but still. The contract company had 4 pages of documentation, and it literally had bullet points, nothing else, like instance name, launch script, variables to edit script, that kind of stuff. So nothing that you would say, we use this file to blah, blah, blah. No. It was like just where what is. All the deployment files were in one place in Git. None of them had any comment in it. Nothing, 0. There was not a single hash mark with a comment in any of the files. So it was like best guess, basically. Yeah, works. They really went with the whole premise of, hey, it compiles, let's ship it. There was no extra documentation. There was, no SSL certificate information. And this application had encrypted communication between pods, between downstream applications, and between input applications. And all of them had different SSL certificates. And we had no clue where they came from, like who actually brought them in. Where do we need to go to fetch them, new ones? Because they were all valid for a year, by the way. So, yeah, we had to actually reverse engineer the documentation, which at that point, that was probably one of the first ones I ever had to do. I mean, normally you reverse engineer deployments and make them better. But they wanted to redeploy the cluster, and they didn't have any documentation to go by. So we actually had to go through all the code and all the lines and see what they do. Copy it, make a test deployment, which, by the way, worked. So you could deploy it again, not like the previous thing, but it was like step-by-step reading. There were 3 of us, and yeah, it took about 6 months, maybe a bit more, maybe 6 months and a few weeks. Around the clock, around the clock when I say it's like full work days, so 9 days, 9 hours every day. We had nothing to go by the time they were done. We had a wiki of, I think, 700 pages, all in all, where every function and everything was documented. We did adjust some things that made no sense when we found it, and like some of the stuff that was in there was actually unnecessary. It didn't do anything. Not necessarily the sleep, but there were loops that checked for APIs in other servers that had actually no bearing on this deployment. Like they didn't need to get there. Nothing. It was just there. I'm assuming somebody copy-pasted that script and just kept going based on it. But yeah, that was like a trick or treat kind of thing. I mean, it was searching, finding, and I think we rebuilt that cluster to get or information out of it maybe 100 times at least, just to get to the next step, figure out what this does, get to the next step, figure out what this does. Killing things, seeing what happens. So because they also reference internal variables that were never mentioned anywhere, so it was like fantastic. And this I qualify as under documenting. 100%. If you build something, write it down. Comments? Sleepy? No? Damn. I really need to step up my game to put people asleep. Under documenting 2. Yeah. This was a bit of a different one, and by the way, this also had a really weird alphanumeric this time references, not just numeric or alpha. So it was a very large cloud-based Kubernetes cluster. I think they had 40 nodes, all in all. It was big, not heavy on the instance side, but very distributed. The deployment script was documented, and I'm being very generous with saying documented here. We had something to go by, but none of the security parts were documented. Like nothing what they did on any kind of security level, because that was a different developer. Now the documentation was handed to a manager who said, cool, this is 40 pages. Delivery accepted. Signed it off, they sent the invoice, everybody left, fantastic. It actually, performed very well, the cluster itself. Like performance was there, bit on the expensive side, in my opinion, for what they were doing with it. But and then one day they decided internally to update it, because obviously new Kubernetes version, you want the new features, cool. And they used that documentation that was given and updated the cluster. The new guy, who had just graduated, improved the application deployment. And they actually managed to get it working in test and dev. And improving is here also in quotes, because if you work on production code, maybe you should have more experience than 2 months. Maybe. I'm just saying, throwing things out there.
But at least you learned.
Yeah, it wasn't me. Oh, and learning is a bit of a stretch here, because he just put his hand up and go, I don't know. That was that thing. So the learning part came later, much later.
That first part is when you admin that you learn.
That's true too. Yeah. So test works, dev works, fantastic. They go, okay, should we do this in production? And new guy goes, sure, it works. Well, it went horribly wrong. Nothing worked. The cluster worked and came up, and that's where it all just stopped. Like none of the applications that they were using worked. They all launched, but you couldn't do anything with them. They wouldn't even respond, even though everything was exactly as it should have been. Fantastic. So when I then got in, it turned out that there were no documentation about any kind of security policies applied. None. Zero. The original script, however, launched them all, and then just didn't, you couldn't change them, because they obviously, when you launch a new cluster, they change the name, the names here and a little bit here, which none of them were referenced. They also had a hard-coded decryption key for some of the volumes that they were mounting. That was not documented anywhere. As a matter of fact, it had a hash not in use X35B7.
It's called secret.
Okay, I get your secret, but then at least write there that this is the secret and not in use, because obviously they didn't use that on the.
But that
Otherwise
makes it
it would
more
not be
secret. That makes it more secret, because you state that, okay, this is not in use, therefore why would anybody care about it?
That's true. To throw off the hacker.
Exactly.
There you go. Yes. That's the conclusion we came as well to. That it's probably for the guy that admins the cluster. Yeah, don't use it. Okay, cool. Yeah, the deployment pipeline was actually documented fairly decently-ish. But the problem was that they left out the SED part that they applied onto the X35B7. So nobody knew what it did. And it wasn't doing it because the name of the cluster had changed, and that was hard-coded somewhere, and reference base64 encoded even, I think. Yeah, they couldn't launch, or they launched the production. Nothing worked. Then they tried to reverse it, as in going back to the old cluster. And at that point, they noticed that the new guy had shut that down. Because you launch and you shut down, obviously. The new guy, by the way, is no longer there. I don't know why that is. Weird. So by the time they actually brought the old cluster back up, which came then back up, I think they had an outage of 2 days-ish. And this was a customer-facing application that was actually used to do in-car entertainment updates. So you can imagine the public damage that it did to that company, because the service was just gone for 2 days. It took us 60 man days to document and to reverse engineer that part to actually get it all into where it was supposed to go. And that was actually not the problem. I mean, they were fairly okay once the servers were back up and the original service was running. Then, you know, they said basically take your time, make sure you have everything and blah, blah, blah. But I think their biggest issue was the public damage that they had. They had so many customers that were so pissed off that they were swamped. The customers were swamped with emails like, hey, what the hell? So yeah, that was also highly underdocumented, in my opinion. That is. Yes?
How come the test and dev succeed?
If I understood correctly, at that point, how he got it to run, certain parts of it were not enabled. So the application ran, but none of the database and the volumes were actually tested through. So he actually managed to get it running, and the security policy he implemented by default was allow all from all. So obviously it worked. And then the test, that was the dev part, and then the test part, he just implemented that too, launched the script, fair enough, works, great. But then for production, he decided to use the actual production launch, which then didn't. So this is the classic example of, you know, I'm using one thing and it works, so let's try the other one now, and I hope it works as well.
It's a proverb of every small difference between your environments will lead to an outage in production.
Yes, of course, obviously. Yeah. No comments?
I think about the new guy dilemma. These figures are from a couple of years back, but I think it's something like, because the industry is growing so fast, so 70% of the developers in the industry have 3 years or less of working experience.
I can believe that.
Yes.
I can believe that. And you can sometimes, well, you can see it too, a lot of times. All right, hold on. Oh, shit, sorry. Why am I here and, damn, there's a slide missing. But okay, see?
Is this the path to success? Mention a table of contents.
Yeah, exactly, the path to success is missing, and I actually had it. I just don't know where it is. Basically, the path to success, I can run through it. Use common sense. Let's start with that, and then start communicating. A lot of times what I've seen is, I actually started the slide with, let's start with a joke. An engineer, a manager, and a customer walk into a bar, because that will never happen, ever. And it should always happen. Yes, I get it. Engineers, you know, don't always necessarily want to talk to managers or customers, and usually you're like, you know, you have your task and you do it, and that's fair enough. And then the manager goes and tells you something, and you're like blah 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 blah. The Charlie Brown teacher, whop whop whop. That's it. And then the customer comes and complains, and you know, it works perfectly on my machine. But I think a lot of times, at least in my experience, one of the biggest pitfalls is the lack of clear communication. And I don't mean, you know, do this. I mean sitting down with either side of that equation of, you know, with the engineers or with the customers, or both actually, and have a clear understanding of what they actually want. Because that understanding is not always there. And if you keep it relatively simple and the customer tells you, hey, we need, okay, a GitLab cluster, we need this and this and this. And an engineer sits there and goes like, well, okay, and then a user goes like, well, but if we do it this way, can I use this? Can I do it this way? You get input that actually probably makes that deployment that I referenced to very obsolete and not working. You would find a lot of issues much more earlier in that process than later in when it's too late. So in my opinion, communication, and then somebody who needs to verify what is delivered, who actually gets it. I'm sorry to say, a sales guy is not qualified to check if a cluster is up and running and works as advertised, or the documentation is exactly what you need. They're not. You can throw them a couple of acronyms, hey, API, SSL, and they're like, oh, okay, done. I'm sorry, I'm not belittling sales guys, but it's not their forte. You need to bring somebody in who actually says, okay, yes, this is okay, or no, this is not okay. And this happens a lot of times, actually very rarely, that you actually get somebody competent. In the case that of the GitLab or even the application, it was signed off by somebody who had zero clue, but the contractor made it look so cool. They had a very cool presentation about it. We did this. It's all here. I mean, yeah, if I wouldn't know any better, I would have signed off on it too. But verification is usually missing. And I know nobody wants to document. I'm front line here. I hate it as well, but it's a necessary evil, and it needs to be done. Questions?
So what kind of documentation processes or policies or strategy do you use then to know what to document and what not?
Well, first and foremost, you can over-document too, by the way.
Yeah, so
yeah, I've seen those too.
The classic of like, if visible equals true, and
Yeah.
the comment is like, if this is visible.
Yeah, exactly. No, don't do that. No, but generally speaking, you should have almost two sets of documentation. One for either the admin or the deployer that knows exactly where goes what, and then one for the developer that references the stuff that you wrote, so they can actually continue on that. I've seen some instances where these two are mixed, and for that company specifically it worked, fair enough. For another it didn't work at all because people just got pissed off that they got the wrong info when they browsed it. But you should document your way of deploying and definitely what you wrote. The if visible true, maybe that's a bit overkill. But generally speaking, like if you write a function that has, does something very big, at least write like a small paragraph, like if you change this, make sure you also check this and it references to this. Documentation does not need to be a book. It doesn't. Most of us, at least the pre-Google people, or the older generation, we understand that, I don't want to read 6 pages about a single function. No, that's not my job. But at least something that gives you an idea of what is going on. You can usually, if you have experience, you can extrapolate the rest of it, and without big issues. But at least something needs to be there, like that people can see, okay, you have something, yes?
Yeah, one of the promises of the Gen AI tooling for developers is to do this documentation automatically for you. Do you have faith in that?
Bullshit. Yeah, sure.
Do it again.
Sure. I'm sure that'll work.
It's the other way around.
Yeah.
It's actually the other way around. People write comments and then they hope that the code will then be written.
Exactly.
Yeah.
And that actually works. Let's just say that it's very early in the AI game to make a conclusion like that. I know that there's hype and, it's the next best thing, and fair enough. We can do amazing things nowadays with AI already. But generative documentation based on code, okay, I'll give ChatGPT the numeric list of functions. Let's see what he comes up with.
Maybe actually you should be writing the tests and let the AI code.
Exactly.
That would be maybe the way.
Yeah, just write, this does this, and then out comes a code. Fantastic. That I could go for. That I can actually see happening. Reverse, you can prove me wrong. Anything else? Sorry, I didn't.
Yeah, no worries.
Go ahead.
Yeah, so about documenting, so do you know also about the history about how did they miss the documents? It also could be that developers are in so much, like, a lot of things to be done and they just forget it, or do you know anything like that kind of history?
Okay. This is gonna come out really wrong, and I apologize up front for everybody. It doesn't matter how busy you are as a developer. If you need to document, you tell the manager, and if they actually sign off, here you go, email, do not document, by all means, skip it. Then it's on them. But it took me a long time and many years to actually get into mode of documenting what I do on a regular basis. I would say once you have it in, it's not necessarily a natural flow, but you can do it easier. But I also think there's a lot of, especially with people that want to do the next cool thing, they just want to get to that point. So it's the skip hop part that I'll do that later. I'll do it tomorrow. I don't remember what I did.
So how do you do the document? It's like while you do the task, that time you do the document, or after finishing and you do it?
I'll do, personally, I write my task or my library or code section or whatever, and when it works, I'll then, like I said, my documentation is not a book. It's a line or two or three about what this does, and that's it. I mean, it's a Visual Studio document that I have open, just, you know, standard Git markup, and just add another part in there. That's even better than having nothing. So even if you commit a Git document, a markup document that just has paragraph after paragraph based on what you did on that day with a topic, that's already something that I can hand you the code and the documentation and say, like, can you go through it and fix it? And then you'll understand, okay, he did this here, did here, did here, did here. Then I get from somebody else a verification, yes, it's all in order, good to go. Does it work? That's irrelevant.
Another question, like you said, like if we use the ChatGPT or like any language model to generate the code, and if you use the code, where's the code? Is it safe to use the code?
No. I wouldn't, but be my guest. I've read, and I think most of us have read the news about, especially like Samsung actually got, they had ChatGPT with their microprocessor architecture, which I thought was quite funny. I have a good friend who works in Samsung, and he said that the proverbial beep storm inside was impressive, to say the least.
But if you use from the Azure, like if you use your own, like OpenAI from there, if you use the code, can you use that one zip or no? It's the same thing.
It's probably the same thing, I would say. It's still, unless you train your language model and you run it, which good luck, by the way, then fair enough. But then you also know what will come more or less out of it. But anything that you get as a service, ish. Yes?
On a side note, by the way, if you're interested in this kind of code AI, what is it? Like
Topic?
IP topics, there's going to be the next to-do meetup.
Yes, and then we have a topic about generative AI and its legal consequences. And I think the question was more like technical, like do you trust that the code is good? And I think you should not.
No.
Yeah, you should be able to verify yourself.
Exactly.
Actually, if the code is valid.
But it's even the promise is not that it will be perfect, like it's an assistant.
Yeah.
So you have to always fix what it spits out.
Yeah, I let ChatGPT to convert some of the GitHub actions to GitLab pipeline, and while the GitLab pipeline most likely would have worked, you can still see that it's making, it created the old-fashioned code. It didn't have up-to-date methodology and stuff there.
Fleur,
yes, sir.
your experiences, because now we know what is this over-engineering under documentations, have a vast experience. So what is the colossal business losses to the business owners? Is there any, they could detectable, or they can create a template that like, well, I mean, this is what the things they should like,
like I said, it actually
How
comes.
much is a big business impact? I'm very interested.
A big business impact, numerical, you mean?
Yeah, numerical. I mean, quantifiable business or like.
Okay, quantifiable.
Because you have to rectify.
Yes.
Like,
Yes.
So what is
So the total, I can give you a number on the web app. That's.
No, approximately what is it a time loss? Or
No, it's a money loss. It's definitely money loss as well. Like, it's not just time. Usually, it in big impact scenarios, it shows up on the balance sheet. So that's.
Suppose say you're launching a big project or something like that, it will be done royally then.
Yeah, and you're right. And this is the problem that when you launch a project, usually you have to do some sort of risk analysis up front.
I'm working with a lot of Microsoft server guys. I mean, I'm helping companies, so I didn't know on the business side, but like when I'm looking at the intricate thing, it's like,
Yeah.
it's scary.
It's very scary, very, very scary. And people just skim over it like, oh, okay.
Like, is there any kind of a group can come up with a template where you have a checks and balances kind of?
I think the problem is that it varies from industry to industry. Like, heavy industry is not the same as tech.
So you can't have a kind of one standard.
Nobody's proud of these numbers.
Yeah.
It's like a rudiments, like these are the
No.
must follow.
I don't. It's more like maybe. I think there are somewhere you can find like lessons learned or best practices. So, but that's more like a guideline than anything
It's
else.
like an American justice system.
Yes. Yeah. The best argument wins.
One common theme that I saw in all of these is that there's a subcontractor who left.
Yes.
Would you say that using fixed-term subcontractors is not a good idea?
No, on the contrary, actually. So I am one, so no. Very much so. No. No, I actually wouldn't. I would say it makes sense in a lot of times. I've seen very successful projects using a lot of subcontractors. But you need to have somebody in-house that actually understands what the hell they're doing too. A lot of these, especially in the projects that I've elaborated, or the scenarios that I elaborated on, they had people internally that, this looks good on a CV, but I've never done this, so, oh, Peter over there, yeah, you look like you could handle this guy. Okay, cool. So there was no concept of what these guys were actually supposed to deliver. And when you deliver something, then the internal guy is happy because he can't really verify what you did. So, but you were busy all day, right? Yes. What did you do? Well, these 50 lines of code. Oh, good. And then they walk away. So, no, subcontracting is, I think, is good. It gives you that opportunity to get a burst, staff, and then kind of let them go. But you need to be sure that you know what you want, and you can verify what they're doing, that you get what you want. That's, I think, the underlying issue here.
So it's the same thing as with ChatGPT. It's an assistant. You don't
Thank
take
you.
it
Exactly.
as it is.
We're just a little smarter than ChatGPT.
Well,
We wish.
Yes, we are, sure. Thank you for this, by the way. I'm sorry I ran over time. My bad.
Good discussion. Okay, but yeah, thank you very much.
Thank you.
Lauren. So now we'll have food, right? Or yeah, I think that was the plan. Okay to have food?
Yes,
Yeah.
please.
Perfect. Yeah. So let's. hope that this works still. Yes. Okay, so let's continue with the crossplane talk. I was just asked if I can do an introduction to crossplane. So yeah, let's do it. And then they can tell about what they have been using it for and more like that. But yeah, so you might know Kubernetes, or Kubernetes has become famous for container orchestration. So if you go to kubernetes.io, it will say that Kubernetes is a container orchestration system, right? But it is really two things. So like when you start, I've been a Kubernetes maintainer many years, and been really actively contributing different subsystems of the project. And when you start looking at it more closely, it's really two different projects. So there's one project which is kind of fundamentally and the most innovative, in my opinion, that kind of expands on the APIs. It kind of sets a format for how do we express things and how do we make APIs interoperable with each other, and also kind of provides a way to build platforms on top. So that there's kind of this underlying layer which provides everything you need to build a distributed platform. And then one implementation of that is to build a container orchestration on top. So like for that, then on top, Kubernetes has become famous for providing some built-in APIs for, well, load balancing and kind of scheduling and all this kind of stuff. But you can actually use this this bottom part of Kubernetes, if you like. I think it's got I/O. I hope I don't. Yeah. This bottom part is actually now another CNCF project, which is just the API server, of Kubernetes, and this actually has everything you need in order to build any kind of control plane for your business. And this is by far the most innovative thing in Kubernetes. Before this, I mean, I have many talks about the implications of this and what it really does. But if you take my word for it now, that on top of this you can build platforms that are declarative and uniform. Then you can do many other things in automation. You can expand from the kind of imperative paradigm of, well, we heard about the scripts here, the talk before this. We heard about what happens when it's like one script that is serial and kind of doesn't have the right checks and balances and stuff. This is all about you make an API that is declarative, you put it into this API server, and then you build some controller that kind of check all the time. Every Kubernetes works like that. Every 30 seconds, it actually goes and checks that, am I running the containers I should be? Am I doing the right thing? And if there's a deviation from what the user said that should happen to what is actually happening, then you try to fix it. Of course, you can't fix all that kind of automated things, so then some of it you might want to fix manual to avoid the over-engineering, but still. So this is the platform, the lower level of Kubernetes, and another CNCF project, and one project that implements another platform on top of Kubernetes, which is not containers, is Crossplane. And Crossplane then takes the task of managing everything that is not inside of your Kubernetes cluster, but is in the cloud. So for example, if you have AWS things that are not directly related to, say, your containers that you would be running in a Kubernetes cluster, you have all kinds of billings and Lambda functions and networks and all these kind of things aside, then you can build a framework for reconciling this, declaratively saying that I want to have these 5 VMs, for example. You specify all the specifications there, and then Crossplane actually goes and talks to the API and Amazon API is imperative, so you actually need to tell things like imperative actions like start, stop, resize, all that kind of stuff. But to this platform, you just say that what is the end goal? Where do I want to get? So it has lots of cool things, nice community. It's one of the great CNCF projects. And well, now we're going to hear about like how Terveystalo is using this. Good.
Thank you.
Let's not start here. Let's do this first. Okay, thanks for Lukas. So, okay. Ja sitten. How do I switch this?
How do we go full screen?
Help.
Is it use slideshow?
What was it?
F5, maybe, who knows?
I think there was command F5 also. Something.
What is this PowerPoint?
Yes, PowerPoint.
Yes, this is PowerPoint.
And there is this present.
Swap display.
Swap displays, yeah.
But then.
But can you go there? Nice.
But then that's wrong.
Yeah. No, it's correct.
Okay, that's great. Yeah, so.
How many IT people did we need?
Next we talk how do we convert.
PowerPoint is a Microsoft product. You need shitload of people.
Next we need to talk and figure how to like convert docx to PDF, but let's get that. So my name is Henri Kovanen. I'm the GCP platform lead at Terveystalo, and this is my sidekick.
Yeah, Robin / Tommi Tampio and DevOps architect currently. Yeah.
So, why Crossplane for us? So, like the buzz around these developer platforms, so building a platform on top of Kubernetes, not just running our applications on Kubernetes. So how do we get like the most out of it without like doing too much of Kubernetes, let's say so. So we wanna we're trying to build something, or we're trying to build a proof of concept of a platform that would help our developers. Like we have many teams that don't really it doesn't matter where the stuff runs. They just wanna put a container and just define that they need these ones and be done with it, and not set up VNets or set up firewall rules or anything like that. Just my container, run it, please. I want to code. So that's what we're trying to achieve and maybe build a business case on. And then our 24/7 operations people, they have 20 projects there, and every one of them is different. So one is on Azure and one is on GCP, and one is built like this and one is built like that. And how does the monitoring work and how does the deployments work? Everything is different, so bringing some kind of opinionated set of tooling to help the guys out a bit. Yeah, so we are in the platform engineering team, so we handle the stuff in the background and work with the dev teams to help them out and move them on their way, so then they can do what they want to do. Yeah, and how we are trying to approach it is GitOps and have everything declaratively. Yes, in Git, everything in Git. So for us, Kubernetes resources do what Kubernetes does best, but how about the cloud resources that the project might need? So we scope this quite narrow, so that we might need topic queues or databases or something like that. So how could we manage those as well with our Kubernetes objects? So we're using Argo CD on the proof of concept. So we have the Kubernetes resources in Git. Argo CD checks that if there's changes and reconciles them with the Kubernetes clusters we have. Then we have Crossplane on the Kubernetes clusters, which looks at, okay, there's now these Crossplane resources, and then it provisions cloud resources for us. So then we have this nice chain of events, and maybe a bit of over engineering at some part. As well. So I felt
this is the best place for us, maybe.
Yes, yeah, I kind of felt a bit of ashamed when we listened to the last talk. So yeah,
Sorry.
It's all good.
Good points, we agree.
Yeah. Yeah, we don't like, we're with you, like totally with you.
And now you even have it documented right there.
Yes. And the manager approved it. Yeah.
We won.
Yeah.
Yeah. But yeah, basically what I was thinking of telling you guys next was a little bit about the details of Crossplane. I would want to see that how many of you have tested Crossplane some way or the other, if anybody could raise hands. Yeah, there's some. Nice. What about Terraform? Nice, okay. I was a little bit expecting this, that Terraform has been around. People know that quite much better, and yeah, I think what we are with Henry is kind of many others, checking out the new kid on the block and seeing how it works basically. But yeah, I want to quickly give you a little heads up of what it looks like, and after that we go into some common thoughts for it. But yeah, basically I'm going to show Crossplane resource creation order. There's basically like 3 things, but actually 4 things that you mainly need to think about when thinking about Kubernetes resources here. The first one is composite resource definition, and that's in short XRD, as they've named it. And basically that one is for the infrastructure operators. And we are trying to keep this at the level that there are 2 different roles. There are the ones in charge of Kubernetes infrastructure and those who are development teams and app teams, and they do different stuff. So basically the infra operators, they create an interface for development and infra teams. So basically I put a little snippet, I hope you can see that, but that is from our proof of concept as an example. And the code looks the way it looks on the right. We are not going to go deep dive, it would take way too long. But yeah.
But essentially, you define an API, what they are.
Yeah, exactly. Yeah.
You define how other people can use your API.
Yeah. And people coming from Terraform, I would like to, there are these references, or you can think them, how do they relate to Crossplane and such. And I would say that maybe you can think XRD is a little bit like Terraform variables. That's the place where you kind of define for your, let's say, Terraform modules that what does it take as an input that you can create resources with later. But yeah, that's how I think about it. And one thing that struck as a surprise for me is, and I think this maybe comes with the CRD stuff usually.
Yep.
I haven't been doing lots of custom resources in Kubernetes, so
it's the same.
Yeah, it's the same thing. But basically, you deal with open API specs, and I think if you're an application developer, you most likely are also aware of open API specs, and have been writing them. But yeah, basically that's what you usually write in these resources. And basically what Lucas said, I think this highlights another point, that these XRDs will create new CRDs, which are the APIs, I would think. Yeah. And yeah, made by infra operators, basically. These are never created by the application teams who want cloud resources.
So one thing, so for those that don't know what CRDs is in turn, then that's the Kubernetes native extension mechanism. So if you want to add your own API to Kubernetes that has nothing with containers to do, again, kind of build another platform on top of Kubernetes, then you use a custom resource definition, abbreviated CRD, a little bit cryptic. But then, and in fact, this Crossplane definition is also a custom resource definition that creates more custom resource definitions.
Yeah. That's something that tripped me also within this talk. This kind of thing, definitely.
Confused yet?
So are we.
Yeah. Yeah. But yeah, that's basically it. Let's go to the next resource, which is the composition. And this is also made by infrastructure operators. and what's the role of it? It's to define how cloud resources are created. So if you come from Terraform, it would be the resources basically that you define for a storage bucket or anything else. That what basically, how is the cloud resource being built? And you can again see it on the right. And you can see there's the referral on the XRD, which we were looking at before. They always refer to those XRDs. And yeah, basically you can see the blue section. That is the place where it actually defines that, okay, what cloud resource are we going to create? And it takes those parameters also that are defined within the XRD Open API specs. You know, that Terraform variable thing. This is like kind of like the module in Terraform, which just basically takes those input parameters and creates the resources, or more exactly tells how to create the resources. And yeah, this is again infrastructure operators. Development teams are probably not going to be doing this. And then lastly, this is the actual part where the cloud resources are getting built. So there are XRs and XRCs, which are composite resource or composite resource claims. And yeah, basically once you create that, then you have cloud resources. And here's an example how it looks. And this maybe tries to bring up the developer experience in all of this cross-plane stuff and trying to abstract away the things that app developers don't need to do, but if they want to have topics and other stuff, they would have a clear interface to get it from, basically. So, you know, if we go back to the composition, app development teams don't need to know anything about what happens under the hood, but they would only need to know the minimum things to get their cloud resource in the way that they want it. I think that's like one big thing in this cross-plane stuff. And yeah, there are namespace scoped that has to deal with role-based access control or access control that who can create resource and where. It's just good to note. And yeah, basically it's like you have a Terraform module. This would be the place in the module section within the code that you put the parameters. I'm talking about the spec field. Yeah, that's that. And just quickly about the XR, it's basically just the same as XRC, but they are cluster scoped and not namespace scoped. And that basically means that XRs are mainly being used by infrastructure operators, not app teams. Let's see what we have. We have Henry up.
Yeah.
But yeah, that's about the resources.
Yeah. Lucas mentioned providers, so there's different providers. So you can do AWS, GCP, Azure. You can write your own if you want. And then there's this nice thing that I just wanted to like give a tidbit for. So there's also this Terraform operator. So if you want something in between, you can do it. And who doesn't love YAML will not love YAML, which has inline HCL. So best of both worlds. You don't have linting, you have to do the indentation correctly. So you can, here's your foot, you can shoot it yourself. But yeah, exactly. So if you want to make your life really miserable and really over-engineer this, you can do it this way as well. Okay, it supports remote backends or remote like as well, so you can have a proper like Terraform setup and
have a null resource that does like ace bicep stuff on everything.
Yeah. But if you're moving from Terraform to Crossplane, then you can like use this in between when you like do the migration. So I think there's a place for this, but I just wanted to test it out and see how nice life can be. It can be really nice. Okay, so what we learned. There's like differences. Like for Terraform, we know how to use it. It's like it's its own language, and YAML, some love it, some don't. Most probably don't. But yeah, it's there. It's like the comparison is you can do it. Yeah, no control structures in cross-plane.
Not that I know.
Yes.
Yeah.
Yes.
Probably at some point it will come. But
Yeah, yeah.
That's another thing.
And I think there was a design decision, or it has been mentioned on the GitHub issues, that if you need to do something really custom, you know, in the patching, or yeah, you need to do this kind of custom thing which might include iteration or conditionals. You would actually need to create a custom container for it in order to run it within Crossplane to do it.
Or can you add those with Terraform? Because it supports those.
Yeah, that's actually a quite funny idea.
And if you want to go deeper, of course, you can use the Kubernetes Terraform provider, or the Kubernetes provider for Terraform to provision the resources, like this.
And the reference back to
yes.
each other.
With numeral.
Yeah,
yes.
like even with the Terraform local exec,
Yeah.
just to confuse things.
Yes.
But yeah, this was something that we were speaking with Henry earlier also, that even with Terraform iteration and conditionals, you can really make stuff like unnecessary complex with it, or then you can abstract away and scale up some resource quite nicely. It's kind of like opinions and different use cases, but I personally I would like to have conditionals and iteration on this stuff. Yeah.
Trade-offs. Yeah, like it's big and it's not like easy. So you have Kubernetes, which is not easy. Then you have this whole new control plane on top of it, which adds like complexity. So it's powerful. You can do a lot with it, but then you need to like pick your battles. So this is a place where you can really like over-engineer it. So those who need it really need it. Most of us probably won't need it. We don't need it.
we want to automate the provisioning of Kubernetes resources by a GitOps controller. We were thinking that could we do the same with cloud resources in a way that, you know, when application development teams have some repository where they have all of these Kubernetes resources, they could have also all of the cloud Kubernetes resources quite close by for them. And basically then that would mean that when there's a new app team or existing that just needs a new app out, they can just define those Kubernetes resources in one repo, and it would take care of creating the whole infrastructure on cloud and all of the stuff needed on Kubernetes. So yeah, going back to the over-engineering.
Yeah.
Basically we are trying to make it like automated as much as possible and seeing that it could scale at the same time also.
Yeah, and maybe like using one tool for the whole delivery part. So if you use Terraform for your resources, then you have to like do it somewhere else because like let's say Argo CD doesn't do Terraform, so it only does the Kubernetes resources, at least out of the box. So then if we would have these like Kubernetes native cloud resources, then we could use one tool and see the whole big picture from that tool and that config management tool. That was the dream.
And then you woke up. No?
Yes.
Then we woke up.
Yes. Yes, please.
How does this compare then to things like Google Config Connector and other?
Excellent question. We had this. We should have added this, but yeah, it kind of does the same. And in let's say with Terraform versus AWS cloud, what's it called?
Controller for Kubernetes.
Yes, yeah.
ACK.
Yeah. So there's like for the big cloud providers, there's these similar operators. So you could use those. We didn't. We might check them next. So it's kind of like comparing Terraform with cloud formation. So cloud agnostic versus cloud specific. Okay. Yeah. Go ahead in the back.
So how do you create the bootstrap kube cluster where your
Terraform
is running?
Yeah, Terraform.
Yeah.
So that we could do it with Crossplane as well, but then the inception thing comes again. So that
The one mention is that the KCP project is just one binary, so you can run it just on your laptop, and then as long as your laptop has the relevant cloud credentials, you know, to the places, then the control plane runs there. It does everything, and then eventually, like.
Good for security running it on your laptop. Fantastic.
Yes, please.
So compared to Terraform, is this a really cloud agnostic cloud definition? So Terraform, I like it, but your cloud SQL is a different definition to Google, Azure, and AWS. Does this provide a mechanism that I want a medium-sized PostgreSQL, I don't care about the details?
It's the same as Terraform.
So
that
it's
you have the
halfway.
you have the providers and you have to do provider specific resources.
A bit sad, but
Yeah, I get you. It would be really nice to have that.
But you can make your own composition so that you have your own API, and then as long as you map them, as long as you map them to the right fields, it's portable.
Yeah, exactly. So you can have that agnosticity, but you need to build it yourself.
Yeah, that's
kind of like Terraform would be maybe also.
You can do it on a mainframe, similar architecture.
How hard can it be? Yes, please.
He was first.
Okay.
Thank you. No, because first of all, that we are actually using this similar approach with MILAB over-engineer, but and one of the reasons why, first of all, we do have Helm as an abstraction layer that allows us to, for example, play around resources that need to be spun up in GCP versus Azure versus AWS, and that also hides away the complexity, a little bit of what we were talking earlier, and that's maybe it's an option for people who look at additional abstraction layers.
Yeah.
On top of abstraction layers, on top of abstraction layers. That's why, by the way, it comes down to study philosophy here. But the other thing that what I wanted to also ask is, I didn't understand exactly what was the reason why you dropped it, especially if you are considering the GitOps approach. because that was the main reason why we actually went this line, because we wanted to have a single lane in which we would define the resources that an application needs versus having to have multiple ways of doing the same thing. So
it's an amazing question, I would say, and it's not really a really easy one to answer.
Yeah.
I would say that
That's
whether
right,
this for us is this, it's yeah.
We would like to use, yeah, we would like to use it, but I think at least for the moment we don't have the resources to use it. So, so it's just the investment in people that we currently don't have.
Yeah.
So if we build a big enough business case for this, then of course, yeah.
Yeah, and one could maybe argue also about the job fair, that how many people know Terraform all hands and how many people know Crossplane, and if we build everything on Crossplane and just leave the company, what are they going to do? Basically, so also those kind of
Hire a consultant.
Yeah, exactly.
There's one guy who's smiling.
But yeah, there were many. Maybe it's also our background that Terraform is really native to us, and maybe I don't know. I'm thinking about scalability also. That when you're in a really big company and you need to scale high, it might be like a bigger reason in that case also to spend resources in this thing. What we are really passionate about is trying to make it as easy for developer as possible. And at the same time, we need to juggle around the complexity that it brings for us and our resources. So that is maybe the main fight that we are thinking about.
That was my question. Thank you for answering.
It was a really good question.
I was going to ask what's the benefits, and you just told me, so I'm silent now. Thank you.
Yeah.
Great.
And you had a question. You had first. Okay.
Yeah. What's the how's the provider support right now? How many providers are there, or can I find my favorite Hetzner provider there and stuff like that?
We focused on the big three, so I can't promise you anything.
I don't know.
Yeah, no. But let's say that the providers themselves could use some more documentation as well. That there's a bit of investigation as well if you want to set it up like.
But about the big three, for example, I feel like Terraform supports everything in AWS.
Yeah.
Is it like that in that too?
I have to say that I'm not maybe the most qualified to say or can remember, but I got the feeling that they are quite in a healthy state within the big three, that people can rely on building on top of them.
Yeah.
At least quite close, but I wouldn't bet on it supporting everything that Terraform or CloudFormation does.
Yeah, you discuss a bit about the access control and security, so I wonder all this that Crossplane has its own way to set up the access control and security, or do you really need to rely on CloudFormation?
Yeah, maybe it's a little bit of a rabbit hole maybe to go into that discussion, but it's a definitely really good question. Just maybe to keep it short and simple, Crossplane connects into the cloud resources using these, forgot their name.
Managed identities or service account or
what was the cluster scope resource for that authentication part? But basically this provider config was the resource name. So basically those are cluster scoped, which app development teams don't get any access like most cluster scoped resources. Basically that means that, well, I think how Crossplane wants it to be done is that infrastructure operators create these provider configs, let's say per namespace or per app development teams, and that provider config has access to only to the cloud resources that app development needs to have. And then you basically just scale those provider configs as you need different kind of permissions into the cloud resources. And then there's this technicality, how do you associate that provider config with those resources, but maybe we don't go there, but basically that's how it goes in a nutshell. Yeah. Okay, maybe that was all. I don't see any raised hands, but really good questions.
Yes, good talk.
And good answers, thank you.
And feel free to ask later also.
is Helm file and what it is in practice. My name is Martti, I already told it earlier. I work here as a DevOps lead here at Supermetrics. I've been doing more than 20 years of this infrastructure stuff. I think it used to be called something different and it's changed names every now and then, every 10 years or so. And these days I go by DevOps, but I think platform engineering is new or whatever it is these days. I've used Kubernetes for a very long time already, maybe starting 2014 or 15, something there. And I love to tinker with technology. I run Kubernetes at home, and I do all kinds of things with this. Enjoy trying out new things. So this thing I'm going to talk today about is Helm file, and it's I think not yet in CNCF radar, or it's using Helm, but it's not a part of the map that was shown earlier. So it's definitely still in the early phases of adoption, but I think it's very cool, and that's why I'm here to show it around. I don't have a lot of slides, and they don't have a lot of content. I'm going to do some short demos. I'm going to tell you why we will be using Helm file instead of Helm directly, how it works, and then explain a little bit on how a typical, I guess, very simple Helm file looks like, and then I'll take questions on how it works. We're actually using Helm file already here at Supermetrics, so we've taken it into use, and it's quite useful as a tool. Everyone probably already knows what Helm is. That's an actual CNCF project, and it's on one of the big icons there, I think. Everyone uses it. There's a lot of public repositories available. All of the applications you can imagine to run on Cube are practically available as a Helm file, so you can deploy a Helm file and have something that more or less works. Helm is reasonably well documented. It has templating. You can learn some Go text template, and you can do use the Helm functions to go even further than that. And then there's a spec with values on how to actually use the templating. And unlike the crossplane, this actually does have iterative functions, and you can loop stuff over, and you can have if-else statements and stuff like that in Helm, which is nice because Cube does not have these things. so you can maybe go a little bit further on the automation on the templating side. And of course, it's pretty robust. Everyone's using it. It's tried and true. It has good versioning support. You can put it on a Git repo. It's easily testable. You can have a Helm chart that you can test, and you can more or less guarantee that using normal configuration it'll work. You can do diffs. You can see if you change it, how would it change in production or staging or wherever you have. You can see what it looks like, and you can of course roll it back. So you can roll it back to the previous version and have atomic releases that you put on, and if it doesn't work, it'll roll back automatically. So all kinds of funky features in Helm itself. So what is missing from Helm? Usually charts don't work alone. You don't just deploy an application. You also want to have monitoring for the application and a bunch of other things. Maybe a database. Maybe you want to use Crossplane to deploy a database for it, or some other funky over-engineered solution. Normally though, no Helm file works, Helm chart works quite alone.
Say what a Helm chart is, if there's some people who don't know.
Oh yeah, Helm chart, if you didn't know, sorry, I maybe glanced it over a little bit. Helm chart is a template to generate a Kubernetes resource. So you can have multiple Kubernetes resources. You can have a bunch of resources that are inherently connected, and you could use a Helm file, for example, to install an application like, I don't know, Prometheus or some other application that comes with potentially custom resources. It comes with role-based access controls, and it comes with deployments and all kinds of things. And you might want to deploy them in order and with some templates. So you don't want to write your name of the application multiple times. You want to use templating and so on. That's Helm. So, and a Helm chart is one of these things, one of the templates. You can have one application, for example, Prometheus is one Helm chart that you can deploy somewhere. But as said, Prometheus often does not work alone. Prometheus is generally a monitoring system, and you want to have something to monitor as well. And when you have multiple Helm charts in use, you don't really have necessarily an easy way to test the combination of all of these charts. And also, when you do GitOps, where do you put your values? You want to use Helm charts, and you want to have them deployed in a certain order, and then you end up with a lot of values files that you want to use for the templating, so you're reusing the charts in various places, and it becomes a mess, and you have to invent your own structure, and it's a lot of work. I want configuration as code. I want to have as close to a declarative state as I can get. So I just want to describe what it should be, and then press enter and get it. And if I change it, then it should change and not want me to delete a resource and fill around with various. And also multiple clusters. We are running already, I think, 6 or 7 kube clusters or more at the moment. And we want to manage all of them. And we have staging and production, and we want to be able to have staging as close to production as it can be. So we want to have repetition and good templating in the sense that we run the same stuff, same combination of Helm charts in multiple places. And of course, some little things like safety. Helm is a very powerful tool. If you Helm install and you were doing development happily in your development cluster, and you run Helm install on some chart, and you had accidentally changed your context to production clusters, then you can accidentally do a lot of damage and remove some stuff that shouldn't be removed, or add some weird stuff into production, so your customers might see, I don't know, whatever web page on the cluster. So yeah, can happen and has happened in various places. All right, so next I'll see if I can change this to showing my terminal and do a quick demo. Moment. Cool. All right. So I wanted to show how to deploy a Helm file. First, I'll show what it looks like. I have a very simple Helm file, which comes in my Vim editor. It describes an environment. So it comes with some values I've set up. We've got a Google project where we're running, a region where we are, we have a cluster name, CNCF demo, and a message, hello world. And these are the values we're operating on this example. We've set up some stuff for Helm. Helm itself takes some arguments. You can let any Helm arguments into the defaults, and you will know these things. And then we generate a kube context from the values that are given above. So we have a project, region, and a cluster name, and those together create the kube context that we use for this one. So I have previously created a very default vanilla GKE cluster that I'm going to use for this.
So it's not case sensitive?
Well, no.
Okay.
Yeah.
Just wondering.
I think the kube context itself.
This is very important.
Focusing on the essence.
Yes, and then I've defined a few repositories. I've got some open source repositories. One is Bitnami by VMware. Then I have a Prometheus community resource and a Grafana Helm chart resource. And these are all open on the internet. I defined this is Helm chart repositories that you could use with regular Helm as well. And then I set up releases. So I'm going to put some static content from a directory locally on my machine. I'm going to add a static web server with some separate values for this. I'm going to add Prometheus for monitoring it, and I'm going to add Grafana for looking at Prometheus, so see if it actually worked. So we can try out and run Helm file, apply, and limit it in this time to only the website. I added a label for website, and it should only deploy the stuff with the label website when I set the limit that I only want to deploy these two resources instead of everything. I could have written in Helm file apply, and it would have applied everything to the cluster, but now I just did the bare minimum. This takes about 40 seconds or so. It actually does install Nginx is a completely empty cluster. There's no resources beforehand, and this might very well fail as a demo effect as well. But here in the before actually running it, and we could have done a diff separately, it shows what it actually rendered as a manifest and is going to put on the cluster. And now it's done. It shows me that the static site took 2 seconds and the static web server took 49 seconds to install. And now if I check the prods here, I should have Nginx running, and the config map is there that I defined. There's a hello CNCF config map, and there should be a service that's open to the internet, because that's how I configured it. And we can see it if we go and download whatever is on the website, and I allow it from my firewall. We can see that it created this resource. It's an Nginx site on the internet that tells us hello world.
Good demo. It worked.
And because it's templated, I could easily go and change some values. I could change hello world to hello CNCF, and run the same apply that I run before. And now it doesn't actually have to install Nginx anymore. It'll just do the change, which it shows here that website has changed. And if I curl it, I get demo effect. Did not actually get the resource. I think I have to refresh it from the Nginx. So reload the Nginx container because it's cached in there.
Kill the pod.
Yes, I can do it.
Yeah, by construction it doesn't it doesn't reload the existing application when the dependency changes. You can do that as well, but you need to make it explicit.
Yes.
So now.
Doesn't that actually rely on how you mount the config map?
Yes.
Yeah.
Also. Answer is always it depends.
Yes, it depends.
But not in this case.
While we're doing that, we can also add the rest of the container. We can say helm file apply, and it'll do the rest. So actually does everything again, but now it'll install Prometheus for us and Grafana for us. It also takes about a minute or so. But this kind of system of defining a cluster can be very powerful. You can quite easily see what's done. It's more or less self-documenting. While we're waiting, I can show it. Go back to the file. And it's self-documented. This is quite easy to read. It's not something that's a lot of magical hieroglyphs and stuff. You can as in the previous demonstration, you can focus on the essentials and something that people can actually understand, whereas the actual charts around or behind this can be quite difficult to comprehend and very complicated. Yeah, I think we've got resources more or less. Here we go. We've got Prometheus running and Grafana running. Here actually the Helm charts themselves come with a lot of informative things. We can, in this case, run to get the Grafana. We can run whatever it says. I've already checked these. Sorry. I'll need an admin password too. You'll see it. Here we go. But you can't access it without having a port forward. So. figure out how to get back
You
to
get,
the presentation.
maybe you can share your whole screen.
Yes, I'll do that. Make the window a bit bigger, and we can go see our Grafana instance that we just installed. Log in with our admin password. And here we are. I already have a data source, and if I go to explore, we can see our Nginx metrics, for example. We can see Nginx connections handled, and run the query, and we can see that it's taking in health checks as a Kubernetes pod would. And if we keep refreshing the page with curl, for example, we should get.
Yeah. And now it's it changed.
Yes.
Like,
Yes. Yeah. With the deployment.
Yeah.
But yeah, this is how you can use Helm file. Comes with a very simple template and can be extremely powerful for these types of deployments. All right, now I'll switch back to my presentation. And go through a little bit what just happened. We had the Helm file, which I showed you in the editor. We defined the environment with some context details and some parameters, and we set some defaults for the Helm to use whenever we're doing deployment. You could set defaults like, are we using atomic deployments, how we're going to handle rollbacks, and a bunch of other details that you would, with using Helm, you would have to do it the same same way every time if you wanted to be consistent. So you would end up with a very, very long Helm command to make it the same everywhere. So these parameters would be there. Then the actual repositories, you would have to add them locally or to a CI/CD system somewhere. Every repository you would have to add and verify and make sure that they're the same. And here you can kind of skip some parts of the steps and make sure that you're using the right thing. It works with both OCI format and with the Helm repositories themselves. And all this you could do with Helm without Helm file just as well. And then the website itself, you would define the content, define some labels if you want to do deployments, partial deployments from a Helm file. You can define some labels and make sure that you're doing the right things in the right order. And you can do partial deployments if you feel that something hasn't changed and you don't want to risk it. And then, yeah, the chart itself here that I showed is just simply a config map, nothing else. A config map with Go text templating in there, and that was deployed. So you can, using this Helm file, you can also refer to local files. You don't actually have to make a Helm chart at all. You can use one simple YAML file with Go text templating on top of that, and it'll able to replace things in there too, which was the config map in this case. And then the second part was to install the Nginx itself using the chart from Bitnami, setting up a version. It wouldn't change unless we wanted to. You could relatively easily also set up something like a dependabot to make sure that you have the correct version, that you know what the implications of having this version is, and then you could merge it and run tests on the next version as well. So version pinning can easily be done on Helm file. And then you can set settings. In addition to values, you can emulate the ---- set in Helm, and in this case we set up the metrics to be enabled in Nginx, and we set it up to use the static site config map from the Hello CNCF config map in the same namespace. And you could do the same with Helm that we did here quite easily.
Question.
Yes.
In that config, you have the labels, but there's no labels in this Helm install command. Does it matter?
These labels actually do not go as far as into Helm or Kubernetes at all. This is Helm internal Helm file internal labels to be able to define filters in Helm file when you deploy it. So as I did in the demo, I limited it only to website for the first part. I didn't actually deploy Prometheus.
So I did use that label?
Yes,
for
I used this label.
Okay,
yes.
Cool.
Was there a reason why you had these labels like website false? Could you just omit those parts?
I could have omitted them. It
Yeah.
doesn't matter. As long as there is label, it wouldn't have kept them in. But in the Helm file, you can do negative limits as well.
Right.
So you can say that everything that doesn't have something. And then for the monitoring stack is very much the same thing. You can define more complicated values if needed. For example, here in the Grafana part, I set up the Prometheus server as a data source automatically to be provisioned when the Grafana starts up, so that you can use the Prometheus that we installed above, and kind of quite easily have complicated values. And all of these values can also be fetched from files. You don't have to actually write them into the Helm file. You can also both template the values files themselves, and you can have them in separate files. Not everything can be has to be in the Helm file. And Helm file also supports running Helm files inside Helm files. So you can overly engineer this too as much as you want. You can go deep on this thing. So you can put the Helm file into Helm file. You can refer to some open source random people's Helm files on the internet too, which seems like a sketchy idea, but you can. You don't have to do everything that you can do. Yeah. So we were able to define the cluster contents in one file, run it quite easily with minimal demo effect. It's templatable, reproducible for other clusters. So if I wanted to run this on another cluster, it would literally be 1 minute of changing values to another cluster, and then I could deploy exactly the same configuration somewhere else. It is pretty safe to run. If I were to change my kube context and try to run the Helm file, it would change it back to the original context that I had before running, so you couldn't accidentally deploy this anywhere else if you have the Helm file context set up. And you can obviously set the entire Helm file into Git or some other version control and have automatic tests to be run. You can deploy it on the dev cluster and see that the deployment works. You can do various things. You can even test the application that you deploy after deployment and so on, as well as then of course having the history of changes everywhere. So I strongly support or kind of suggest to try it out. It's available on the internet, github.com/helmfile. It also comes with GitHub Actions. There's ready-made GitHub Actions and all kinds of things to support this structure, and quite a few users already. It's a relatively fast-moving project. They're going forward. So that was it for the presentation part. Any questions?
You go for it.
Yeah, you mentioned that the reason why you adopted this was because you wanted to have the Clarity White to list all of the charts that you're using for the different clusters that you operate. Is it the practice that you're going to have a single Helm file with all the applications and chart files, and then apply formal values files to that for each different environment, or how do you manage that at the moment?
Excellent question. At the moment, we have one Helm file for per each cluster we have. We could consolidate that down a little bit and try to make it less Helm files. They do have some repetition at the moment, but we didn't want to over-engineer it first. We want to build it first and then see where we could optimize a little bit. And the other part is that we're actually not trying to deploy the application or the Supermetric software using Helm files. So that would be closer to the developer, and we try to set up the infrastructure part and the environment the cube needs to be running, monitoring secrets, cluster-wide stuff, and all this business that's needed on a lot of clusters using Helm file. And then the application deployment is closer to the deployment tool and has a different kind of cycle that it comes in with.
Yeah, I sort of had an answer to that. It supports also environments, so you can have like very small things overrides for in the environment.
Yes, maybe I glossed it over a little bit. I can show it here. So the environments, I have here the default environment. I could have staging and prod, and you can say, have multiple defined on the same file. And when you run Helm file, you can say that this environment is now for prod. Also, you can do this, and it's relatively easy to consolidate a bunch of Helm files into one. You don't have to repeat.
Maybe a second feature that wasn't presented was that it actually supports a log file too, so you can just have your charts there and reconcile, and it writes a log file where all the versions are like pretty much like you would have in like any kind of NPM project or Python project with a Git and so on. So then you can actually continuously just sync stuff.
So when you define the, create a template, does it matter the order of the template? Like you have, like for example, if in your case, like Grafana, Prometheus are not hard dependents on your website. But if you have like database, does it have to be like in order? Like I first create some database and then.
So you can define an order, and you can define dependencies. So you can say that this release requires the other release, and the other release will be deployed then first. So you can define dependencies, and you can define an order that they go into. Here I also had the wait set as true, but Helm file can also work asynchronously, so I could set the wait as false to the global settings, and then it would just let them go, or deploy the manifests and then not follow up if it actually worked or not. So that way you can deploy multiple resources simultaneously, and it can, in some cases, be a speed issue that you want to just fire off and go do the next thing.
So who does these deployments? So like, do you have some kind of, is that automated, or do you have someone on their laptop that kind of
at the moment it's not automated. So we do it manually on our operator machines, but it is easily automatable, and we do have the structure to go towards that direction. But at the moment it's still quite heavily in development, so we haven't automated it. But as said, the GitHub Actions for automating this also already exists. You don't have to write themselves. You don't have to write them. So there's a lot of things that you can do, but we're at the moment not doing. This is more or less a safety issue. We're trying to tread carefully and try to make sure that we don't accidentally break anything.
Makes sense. Did you consider using GitOps? GitOps also has the same like Flux or something like that. Yes. There you also can define all of those same things.
Yes, I think we have looked into those, and we're trying to make it as simple as we can make it. I think this Helm file, the Helm file is more or less a wrapper on top of Helm, and it can produce a very, very simple and understandable end result, which is not necessarily true for all of the other options, which can be great, and they have definitely some other good qualities that Helm file does not have. But this has a good thing going for it in terms of simplicity and understandability.
You could even use both.
Yes.
You could, Argo CD can be extended to use Helm file, for example.
Yes.
Yeah, let's say you have like a simple application which also needs like a chart that also needs like a database. What would be easier, like to have just a chart with a dependency of another chart, or have it like a Helm file where you bring them together and then you have the dependencies?
Well, I think it's easiest to have them as close together as possible.
You ran out of battery, I think.
No, it wasn't me.
No,
It
it's
was
a
you
screen.
ran
Yeah.
out of battery.
It did say before.
Yeah.
Shutting down in 5 minutes.
Yes.
5 minutes ago.
Yeah.
But it's
So yeah, you can, if you're using stuff like the Google Config Connector, for example, or Crossplane, you can define your database and just simply as one release, and then have the other one depend on it if it needs the database to be alive, and then refer to that. And we actually have it already. We're using the Ivan operator. We have set up a database, Postgres database, and it puts the credentials back to the cube, and then the next release can already refer to those credentials and connect to the database. So no one gets to see the password in between.
To just continue on that a bit, oftentimes in Cube it's not relevant to have an order in that. Like you spin up the database, you spin up the application liveness probe goes through when the database is accessible, so you can spawn them at the same time. But it is relevant in Helm file case many times when you have some sort of an operator, for example, cert manager that creates a issuer type CRDs. So obviously we need to have the CRDs installed first before we can have another release that is using. So in that case, the dependencies come really handy.
Yes, excellent point.
To add up this dependency question, so can I also like define dependency to one Helm file to other Helm file? Because defining of like a lot of, if you have a lot of components, so defining everything in a one file can be quite like painless. So can I get like that kind of? Like,
That's actually a very good question. I think you can, but it's a little bit, because you can't consider the other Helm file as a black box anymore. You have to refer to a release that comes from that Helm file. So as long as you know the release name, you can depend that this release name needs to be installed. It doesn't matter that if it's on the same Helm file or not.
Yeah, when you use other Helm files, you can actually like render the final Helm file, so it's going to be actually one single Helm file it executes. After also, in that sense, it's a dependency, but you can like refer to it.
Any more questions? Okay, seems quite good. All right, thank you very much.
Thank you.
So we still have time until 9?
Yes. Yeah, we need to leave by 9, so we've got half an hour. Feel free to take beer from the fridge and drinks from the fridge and whatever food we have left. So.